Case file open, blood sugar spikes are not only about sugar. Sugar raises glucose fast, but excess fat can jam insulin's signal. This investigation follows the hidden accomplice inside muscle, liver, and aging cells. Picture a crime scene inside the body. Glucose knocks on the cell door, insulin holds the key, but fatty buildup blocks the lock. Sugar enters slower, stays longer, and the bloodstream shows the evidence. First clue, carbohydrates become glucose directly, so they can raise blood sugar quickly. But that is only half the story. The bigger pattern is what makes cells stop responding properly after meals. Second clue, when too much fat circulates, especially after frequent high-fat eating, cells can ignore insulin. Then the same bowl of rice or dessert causes a longer glucose surge than before. Think of insulin as a detective badge granting glucose entry. Excess fat strips respect from that badge. The message gets ignored, traffic backs up in blood, and the lab report suddenly looks guilty. Muscle is a major glucose sink. When fat byproducts pile up there, muscles pull in less glucose after meals. That means more sugar remains in circulation, exactly where repeated spikes damage health. The liver joins the conspiracy too. Insulin should tell the liver to calm glucose output, but excess fat can make the liver resist that message, so it keeps releasing glucose when it should slow down. This is why some people say, I barely ate sugar, but my glucose still climbed. While meal may include refined carbs, yes, a background insulin resistance from excess fat can magnify the rise. Not all fats act identically. The strongest concern is usually excess saturated fat and chronic overnutrition, not a tiny amount of olive oil on vegetables. Dose, context, food pattern, and body state matter. Here's the simple rule. Sugar can pull the trigger fast, but insulin resistance loads the gun. When fat lessens resistance, the body handles carbs poorly, and every meal becomes metabolically louder. Now, the aging angle, repeated glucose spikes, insulin resistance, and excess energy can accelerate pathways linked to metabolic aging. That does not prove one food causes aging alone, but it raises long-term risk. High glucose can increase oxidative stress. The sticky matrices watch closely. That is why stable glucose matters not just for diabetes prevention, but also for preserving healthier aging. Imagine a fingerprint dusting scene on cell membranes. Investigators find fat fragments, inflammatory signals, and disrupted insulin messaging. The case is not cartoon simple, yet the pattern repeatedly points toward impaired glucose control. Important correction for the public. This is not a claim that fruit causes diabetes or that all carbohydrate is bad. Whole foods with fiber behave differently from refined, ultra-processed, rapidly absorbed carbohydrates. Likewise, this is not a claim that every oil is poison. The problem grows when total energy is excessive, saturated fat is high, fiber is low, and movement is missing from daily life. Study 1. Bowden and colleagues used lipid infusion in healthy men during controlled insulin clamp experiments. Result: higher free fatty acids reduced insulin-stimulated glucose use, showing fat can directly induce insulin resistance. That study matters because it isolated mechanism. Instead of vague diet stories, researchers raised circulating fat in a controlled setting and measured glucose handling carefully. The metabolic signal weakened fast under higher fatty acid exposure. Study 2. Vespi and colleagues ran the Can-Wu trial, a 3-month controlled diet study in healthy adults. Replacing saturated fat with monounsaturated fat proved stimulatory when total fat intake stayed moderate. That result does not mean carbohydrates are harmless. It means fat quality matters. Its fat tended to worsen insulin action, while monounsaturated fat performed better in the trial's controlled dietary comparison. Study 3. Imamura and colleagues pooled randomized feeding trials in a systematic review and meta-analysis. Replacing saturated fat or carbohydrate with polyunsaturated generally improved several glucose and insulin homeostasis markers. Meta-analyses are not magic, but they help check whether one flashy finding stands alone. Here, the broader pattern still suggested that dietary fat type influences how the body manages glucose over time. So where does visible sugar fit? It remains important. Soda, sweets, juice, and refined starch can raise glucose quickly. The real lesson is that poor glucose control often reflects both incoming carbs and resistant cells. That is why two people can eat the same dessert and show different glucose curves. One has cells responding well, the other has metabolic traffic congestion, often shaped by excess fat, inactivity, and sleep disruption. Hidden fats often arise wearing innocent disguises: fried foods, pastries, fast food sauces, processed meats, creamy snacks, and oversized restaurant meals. These can quietly worsen insulin resistance while refined carbs handle the immediate spike. Hidden sugars and refined starches also matter: sweet drinks, white bread, candies, sweet cereals, and desserts. The public gets misled when influencers blame only one suspect while the entire dietary crime scene is ignored. Another suspect is excess calorie load itself. Even foods marketed as keto, clean, or healthy can overwhelm metabolism when eaten chronically in surplus. The body stores the overflow, and insulin signaling can deteriorate. Physical inactivity makes the case worse. Active muscle acts like a glucose vacuum cleaner. Inactive muscle leaves more glucose outside the cells, so the same meal can produce a higher blood sugar reading. Poor sleep tampers with the evidence. Short sleep and circadian disruption can worsen insulin sensitivity to fats and carbohydrates harder to manage. Metabolism is a full system, not a single villain story. Stress enters the interrogation room too. Stress hormones can push glucose upward by telling the liver to release more fuel. That means food quality matters, but the body's internal environment matters as well. For viewers chasing BioAge reversal, the message is strategic, not fear-based. Reduce the factors that create repeated glucose fat, refined carbohydrate overload, inactivity, poor sleep, central weight gain, and stress. Practical move 1, build meals around protein, vegetables, legumes, intact grains, and high-fiber foods. Fiber slows absorption and improves fullness, which can help flatten sharp glucose surges after eating. Practical move 2, swap some saturated fat sources for unsaturated ones such as nuts, seeds, olive oil, avocado, and fish. The goal is not perfection, but a better metabolic environment. Practical move 3, walk after meals. Even a short post-meal walk can improve glucose disposal because working muscles pull sugar from blood more effectively. That simple habit is metabolically underrated. Practical move 4, watch liquid calories. Sugary drinks hit fast, and fatty coffee desserts can combine sugar and fat in one concentrated metabolic assault. That duo can be especially rough for insulin-resistant viewers. Practical move 5, monitor, do not guess. A glucose meter or continuous monitor can reveal which meals trigger long spikes. Real data beats internet ideology every time in nutrition crime scene analysis. One more nuance. Fat in a mixed meal can sometimes slow stomach emptying, which may delay the glucose peak. But that does not erase the longer-term insulin resistance problem caused by excess fat. So the timeline matters. Sugar and refined starch often raise glucose acutely. Excess fat, especially saturated and chronic surplus, can worsen the background terrain, making future spikes larger and recovery slower. This is why the strongest statement is not sugar versus fat. The real biology is interaction. Direct glucose load, insulin sensitivity, liver output, muscle uptake, sleep, stress, and activity all shape the outcome. When a channel claims one food explains everything, skepticism is healthy. Good science rarely works like courtroom drama with one criminal. Metabolic disease is usually a network case with multiple cooperating suspects. Still, one suspect deserves more public attention: excess fat inside tissues. People often focus only on sugar grams, while ignoring insulin resistance that determines whether those grams become a brief rise or prolonged spike. Consider waist gain as physical evidence. Visceral fat around organs is metabolically active and often linked with insulin resistance. The investigation is not about appearance, it is about what that tissue does. The best prevention strategy is boring but powerful. Consistent movement, better sleep, more fiber, less ultra-processed food, and smarter fat quality. In metabolic forensics, ordinary habits often beat dramatic hacks. The takeaway for longevity is straightforward. Better glucose control supports healthier eating biology. Less metabolic chaos means less wear from glycation, inflammation, and oxidative stress, which are all linked to age-related decline. So the final verdict is this: sugar matters, but fat matters too, especially when it drives insulin resistance. The smartest message is balance, mechanism, and prevention, not simplistic blame or viral absolutism. BioAge Lab can frame the mystery like this: the obvious suspect is sugar, but the hidden accomplice is excess fat impairing insulin action. Solve both, and glucose control becomes calmer and more age-resilient. Final evidence board: direct carbs raise glucose, excess fat can worsen insulin resistance, and better lifestyle patterns improve the response. Viewers should leave informed, not frightened, and ready to test smarter habits. Closing line: the glucose spike is not a one-suspect crime. Sugar can spark it, fat can amplify it, and lifestyle sets the scene. That is the real biology behind smarter aging.